Thank you, and this is work also supported by ZeroXPark, so thank you. This is me. I built an Ethereum-based financial services company, built some MPC communication, and did some work for DARPA, and including turning machine learning models into systems of polynomial equations. This is me with an enigma when the NSA came to visit my classroom. It was a friendly visit, I think. I want to thank people who have contributed to this project, Ying Tong, especially. We did a project this summer, and Alex Camuto in the last week has done a lot, and then upstream Han at PSC and Strat at ECC have done a lot of work optimizing the backend so that the stuff will run. If you've been asleep all day, zero-knowledge proofs are to digital signatures as Ethereum is to Bitcoin. They let you replace the fixed signature function with any program. That lets us move computation from the chain to the client in a trust way, as you heard about. And the thesis of this talk is that the most interesting program that we can put in a ZKP is actually a machine learning model, because it feels like the model runs on chain. And this kind of makes the chain more autonomous and smart. So why do we want to do this? So I'll think about it as a way to give the blockchain eyes, ears, fingers to perceive the physical world, to take observations that we, from cameras or sound, captured in any way data, and bring it into something that the blockchain can understand by running it through a model. The ultimate goal to me is an identity model where we make it possible for a human, not just a field element, to own a digital asset, right? So all our digital assets right now are behind some secret field element, but it's not how we normally own things. Normally, I can do something like say, I want to send 10 ETH to Brian, and any of you who know me would be able to authenticate me and execute that transaction. The fact that we can't do that right now with blockchain is just a technical problem. And I think the solution to that problem involves putting machine learning models on chain. Another way of interpreting it is that it lets smart contracts exercise judgment, right? That's a type of judgment. And was I making this request? What was my intent? But they can do other kinds of judgment, like did someone perform the task they promised to perform for a DAO? So smarter smart contracts. And then there's off-chain applications like proving that a model is unbiased, right? So I say I have a model for screening CVs, and I want to prove that it doesn't discriminate without revealing the model. OK, and when does it happen? It is basically happening right now. So what we've built is a PyTorch-like DSL for deep neural networks. It's built in Halo 2. Has convolution, all the usual layers you'd expect. Some of them are still in progress. It's enough to build production models in, multi-layer perceptrons, convolutional neural networks. We're working on attention models right now. And we achieved the hello world of machine learning, which is MNIST inference inside of a snark in the summer. And it's getting better. So in the last month, our memory usage, which is kind of our constraint, is down 85%, and the speed is up about 20%. So at this rate, we should have GPT fitting in I don't know how many months, but all we have to do is keep that up. OK, so yet another way to think about what we're doing here is to create some kind of scalable automated oracle, a bit like what the Minute folks talked about earlier. And that has 3 stages. The first one is ingestion. So I can ingest a piece of data that's signed or unsigned. Unsigned means I claim it's true. And if there's a ton of evidence, then it contributes, right? A signed piece of data is something that someone has signed, like an email, a signed endpoint for an API, something like that, right? So we check the signature. Then we run our model on a text model if it was a news story, maybe an image classification model if it was a photograph of a hot dog or not a hot dog. And then we ultimately put it on chain with a verification. And then once it's verified on there by different attestation methods, we can sort of put it back into the canon, right? So this is how we're opening kind of a fire hose to get information from the physical world onto the chain. So first, let me talk about signed ingestion. So the truth is, the picture is not that great right now, but it's about to change. So there's a couple of different technologies. One is called SXG as opposed to SGX. SXG is a signed HTTP exchange protocol that's introduced by Google. Cloudflare has a one-click. If you use Cloudflare, you can turn it on with one click. Email, as mentioned earlier today, there's a DKIM signature scheme. There's a big push to combat fake news from this organization called C2PA, which lets publishers of news sign images and stories, so that if someone reshares an image and says, "Oh, this was at New York Times," you can actually check that the New York Times published that. So those signatures we can consume too. And even at the level of the camera, there are now cameras available made by Sony and others that have a built-in signature targeted at places where the image is really valuable. Like you're trying to decide whether to pay off an insurance claim, and you like I would like to put it so they make it so that the chain is that it's on chain the decision making, right? And they all use standard signature schemes that we know how to verify. So this is the Cloudflare website. You literally, if you're using Cloudflare and you pay them a lot of money, you can just click a box and your stuff will start getting signed. Please do that. A lot of people have signed up to do it. In truth, not many people are doing it yet, but they promise to soon. Okay. All right, so the middle part, the text models, image classification. The stage we're at now is trying to make the models bigger. I mentioned the proof of concept from the summer. We were at 107 gigabytes to do MNIST inference. It's now down to 15. There's a lot of low-hanging fruit because Halo 2 is written with Orchard circuit in mind, and this circuit has different properties. Once we expose the issues, it's actually quite quick to fix them. That's why we're getting to GPT-3 soon. And we also have aggregation working now that lets us split proofs horizontally, vertically, hopefully recursion soon. And the big thing that we might do is to add matrix multiplication or convolution arguments, talking to Justin Thaler about that, who wrote that paper. And then, right now we're trying to make known good models work well, but the computational model is very different from the GPU-TPU model. And so we would like to have kind of polynomial sympathy, like mechanical sympathy, in our models eventually. But right now, we're just trying to get something to work. And then verification. So verification is tricky. So we use the Halo 2 fork, the PSE Halo 2 fork, which uses KGG commitments. HEN is not an abbreviation. That's just Han from from PSE, who has been so helpful that he deserves his own acronym. There's two strategies. One is make a single EVM assembly circuit that you can use to verify. It's expensive. The contract is too big to deploy once the circuit is interesting. So if I have a one-layer circuit with four inputs, then it's almost at the contract limit size, but it works. And then that pushes to the next strategy, which is aggregation. So now we're doing some MNIST proof on a client, a laptop or something, at the limit of what it can do at the moment. But the principle, it's a wide, fast proof. Too big to verify on chain, as we just saw. But then we can run a compressor, aggregator, that takes that proof, and it can take multiple versions, multiple copies of that proof, or even other proofs, compress that down to a easy to verify thing. It takes 600,000 gas to verify, but you can do multiple proofs, and it works. This is a small 4-layer perceptron, which I can run on my laptop to do the MNIST convolution. I just finally got that working like last night at the slide deadline time. It took a mere 450 gigabytes of RAM and 2.5 hours. So fortunately, there's a lot of optimization opportunities still here, but it works. The point is we can verify a convolutional network on the EVM. And this is the picture of this. So basically, you have clients, relatively weak. They take in data, hopefully signed, if people live up to their promises. They do a easy to make, hard to verify proof, relatively easy to make. And then those get compressed by the 450 gigabyte server into a short, easy to verify proof, which then gets checked on chain. And the result is that Ethereum can read the news, or will be able to read the news very soon. And it's my belief that ZKML is kind of going to be table stakes for chains going forward. So if we want to deliver on this promise of blockchain for the mass audience, we have to have a more robust way of representing your intent and your control over digital assets, right? So most people are not ever going to invest their entire life savings into a secret field element that they can lose. And they want to own it in the same way they own their rest of their property. If their house burns down, it's still theirs. That'll take years to build, but I think it's possible, and it will get there. You could think about it as instead of two-factor authentication, two-factor verification when you want to send money, it's like 1,000-factor authentication. It looks at your entire stream of data exhaust, runs models on everything. It knows whether you've moved a little bit, whether your devices are there. I can't teleport to, another part of the world, so I know that won't work, stuff like that, right? And then this oracle story, so the ZKML oracles are just way more scalable than a solution that uses complex cryptoeconomics. So this set of humans make a judgment, they stake some money, another set of humans judge the first set of humans, and the whole thing takes hours or weeks to resolve. With ZKML and signed inputs, we can be in a situation where a single person downloads a news story from Bloomberg, runs the model, uploads it. Now the chain knows that Bloomberg says that so-and-so won the election or whatever happened, right? That just opens the fire hose to get data onto the chain. And finally, this idea of a smart judge, I think we can put the A back, autonomous back into DAO, and instead of using human judgment, votes, and multisigs, we can have true automation, where it's as though the organization, the smart contract, is actually making decisions itself. Roadmap, please sign your endpoints if you use Cloudflare, check that little box. And if you do, let me know, and I'll try to consume it, and that would be really fun. We have to work on a lot more on optimizations, get that 450 gigabytes down by 85% or 99%. Infrastructure support to build apps, plumbing and ergonomics. So the library is really rough right now, but we're going to push to make it a lot easier to use. We want lots of interoperable and well-audited components. This is a broader thing for ZK, right? We need a lot of small components that everyone trusts to work, just like we trust the signatures. We're also involved in this benchmark project to try to identify that kind of standard library of circuits and ingesting gadgets. Most importantly, we'd love to hear about your ideas for applications of this stuff. And here's the repo that you can check out. It's Halo 2 Deep Learning. Got reformatted a little bit. And please keep in mind, this is in the it's always tempting to wait until your code is really ready to release it. This is the far opposite end of that. It's very rough and in progress, but I want to share it anyway, because I think that's the right way to do it. And that's it. Thank you.